This next video, we are going to use a table to go through and do our function composition. So we're going to start with this first one here as f of g of 2. So how we start is, again, here is our f function, here is our g of function. So the first one we want is to know what g of 2 is. So we go to 2 on the x, and our output value is 1. So f of g of 2 turns into f of 1. So we go to our f function, find out where 1 is, and we are going to get 3. Okay, for the next function, we're going to do g of f of 2. Again, we are going to start with our innermost function, which in this case is f of 2. So we go to our input value of 2, and now the output value with that is 4. Again, we're working off the f function because that's our innermost piece. So this turns into g of 4. So now we go to our g function, find 4, and its output value is going to be 2. The next one, we are going to do f of 2. Again, we start with the insidemost function. So we are going to figure out what is f of 2. So we go to 2, look at the output value, it's 4. So this turns into f of 4. Again, we go to 4 now in f because we're still working with that. Our answer is going to be 1. Lastly, we are going to look at what is g of 2. So we start with g of 2. The output value is 1, so this turns into g of 1. We look at g of 1. The output value is going to be 4. Again, always start with the insidemost function, identify what that is, and then you're able to move on to the next one. Okay. We have a word problem example here. So a meteorologist is inflating a spherical balloon with helium gas. The radius of the balloon is changing at a rate of 1.5 meters per second. Express the volume of the balloon as a function of t. So the first thing that we have to know is that the formula for the volume of a sphere is 4/3 pi r cubed. And it tells us that the radius is increasing at a rate of 1.5 centimeters per second. So we would write that as the radius is growing at 1.5 t. So at the first second, it goes up by 1.5 for every t value you plug in. So it says it wants us to express this as a function of time. So really what we're going to do is take out this v, we're going to plug in this radius part into the radius part of this function for our volume. So we're going to do 4/3 pi times 1.5 t cubed. And we're just going to simplify that. So this is 4/3 pi, and then 1.5 cubed is going to be 27/8. Because, again, 3.5 or 1.5 is the same as doing 3/2. So we can cube both of those, t cubed, simplify our fractions. So we get 9/2 pi t cubed is our relationship for our volume. In this next example, we are going to work backwards. And essentially, this is what we know what f of g equals, which is going to be 2x plus 5 to the 8th power. So what we are trying to do is figure out what is our f function and what is our g function, that when we plug g into f, we get this as our final answer. And again, there can be multiple answers here, so you could have something different than your partner, and that's okay. How I do this is I start with the innermost piece. So I know I'm plugging g into f, so I'm just going to start with this inside piece of this function, and I'm going to make g of x 2x plus 5. So then f of x has to be x to the 8th, because when I plug this into this, I'm going to get that answer. Another option that you could do is you could say, I'm going to make g of x 2x plus 5 squared. Then f of x could be x to the 4th, because when you plug in this to this, you still get 2x plus 5 to the 8th. So really, you can do any combination you want to, but you just have to make sure that when you plug in g to f, you get the final answer that you started out with. Okay? And next here, we want to do f of g of 3. So I'm going to start out and find out what g of 3 is. So that is really just going to be f of the root 3. So I'm going to take root 3, plug it in for x. And when I do that, these cancel out. So it'll be 3 minus 16, which is going to be negative 13. Okay. Lastly, we already did this f of g of x. Again, we are going to take root x and plug it in for x in f. And when we do that, we get x minus 16. So, and again, we already said that our domain is 0 to infinity, because that's going to take over. The domain here is 0 to infinity. So even when we plug it in and we drop out, we're just looking at 0 to infinity. So we plot our y-intercept, which is negative 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Our slope is 1. So it just becomes a ray. It ends here and goes up forever. So thank you for your time here. We are not going, you don't have to do the last example, example 9. At this time, go ahead and do for the check for understanding. Please let me know if you have any questions.